everyone. In this lecture, we'll cover the process flow diagram to get us started on our capacity analysis calculations so that we can quantitatively evaluate the performance of our processes. Our learning objectives are to define what a business process is, understand how process flow diagrams can be used to model a business process, and identify the flow unit in the process. We want to be able to construct a process flow diagram and consider what are important process measures for our process. From course 1, I think you remember as a part of Measure, we discussed the importance of process mapping. And we created these process flow charts like this T for Mum chart. We defined process mapping as first identifying all the steps in a process and mapping these steps as they occur. We needed to identify the inputs, the outputs, and the controls at each step. We used our process maps in order to be able to better understand the process for then discussion and brainstorming in process improvement projects. Now in this course, we need to take this one step further because we're interested in the performance of our process as a whole, not in just one critical to quality variable. We need to go back to our process maps one more time and create process flow diagrams that we can then use to quantify our process performance. But first, let's define what we mean by a business process. And here we're interested, of course, in processes for companies which will impact our business success. So a business process is a repeatable, coherent sequence of activities which consumes time and resources. It has a clearly defined input and will result in a certain material or immaterial achievement or the output for internal and external customers. And what's important here is that processes are repeated. For example, this could be a process for the assembly of a certain type of product or for a certain testing of a product. This could be the process for approving a loan or a process for receiving an order or a process for shipping. This is not a one-time project. This is not a one-time event. We're looking at a sequence of activities which repeats itself often as the business runs. Now, as we discussed, in the context of mass production, a business process is the volume production of goods or services. Again, a sequence of set and limited activities performed by a set of specialized resources. Our process transforms inputs into outputs using the time and resources. And for example, if we had a skateboard, you need inputs, and we have some particular inputs. We have, for example, the deck, which is the board that you would stand on, the wooden board. Then you have the so-called trucks, and these are these large metal pieces that attach to the board, and they will house the axle, and you can attach the wheels to them. You have a bunch of wheels. Now, there's different types of wheels depending on the different type of skateboard you have. You'll have some bearings with those wheels. Those can be steel or ceramic, and steel is standard, but ceramic has less friction, so different types of costs involved there. And then, of course, you have nuts and bolts and things that are needed to put your board together. Now, these inputs are then entered into our process, and we then produce as an output to our series of activities with our resources into a finished skateboard. Now, in a much more complex process, for example, semiconductor wafer processing, a silicon wafer will go through hundreds of processing steps in what we call a fabrication plant, or fab. Now, these fabs cost billions of dollars to build. And the process for fabricating an integrated circuit on a piece of silicon wafer takes several months. The wafers are then sent to a storage area known as the die bank. The individual chips are called dies, and then are sliced up and packaged and tested. This slicing and packaging and testing then also takes several weeks. Now, in this high-tech, high-volume production where there are many, many process steps, and remember our discussion from course 1, when you have many, many process steps, you're very then interested in the yield. Our process analysis becomes much more complicated than making simply tea. Here are some photos, for example, we have for the packaging process. Maybe we could erase this. No. We look here at the package test, and again, that takes several weeks. You start with the material wafer on the die bank. This is where the wafers are stored in a very, very clean environment. Then they need to be sawn up or diced into individual die and then attached to a substrate. And these tiny little wires are attached. These are then encased in a plastic molding, and then they're finally tested. And then they're sent to mark, scan, and pack, where the chips are normally packed, as we showed here, in tubes or trays or tape. Now, we're not experts here. Most of us have never been inside an integrated circuit assembly plant. But we can, all of us, analyze this process if we have a few key pieces of information. So the first thing to do is to rearrange our elements into the flow that we've just seen. And then we want to draw the process using our process mapping tools, the same as before. We have the triangles for storage, for example, from the die bank, and rectangles for operations. So here we have our silicon wafers at the die bank. We move into sawing the silicon chips up and assembling them, attaching them to a substrate, attaching the wires, and doing the plastic molding. Then we have the final test and mark, scan, and pack before they are then stored as packaged chips ready to be shipped to customers. Of course, it may be that we need to go deeper into the process. Here we can break up our sawing and assembly into different constituent steps: saw, die attach, wire bond, mold, plate, trim and form, and singulation, which here means singulation, cutting the chips up into the individual integrated circuits. So looking at this with our Six Sigma hat, now we could have identified a critical to quality measure in parameter in define, and then in measure we would have undertaken steps to measure the established baseline performance. Then using our process maps and inputs from experts, we would look for influencing factors in our process. In analyze, we would establish the cause and effect relationships and propose and test improvements and improve. Now we're going to go, maybe we could say up a level, and take a broader view and measure somewhat different process performance measures for the entire process. And this top level view will allow us to perform some very powerful calculations. But let's go back to our more simple and more colorful skateboard factory. What do we see here? Well, we have our raw materials. We already talked about them: the wheels, the truck, the deck. Our first step is to assemble these parts together into making a skateboard. Then we want to sand our skateboard down, and finally we want to paint. So we have our 3 process steps there, and we have our finished goods, then are the finished skateboard. So what unit are we working with here? What are we interested in? What is flowing through our process? Well, I could say our unit here is a skateboard. We're interested in how many skateboards we get out of our process. This is called our flow unit. Now, for a different type of process, like a continuous flow process, we might be interested in a liter of milk, or a gallon of milk, or a gallon of beer, for example. Later we'll see that if we work in batches, then we could have a unit of interest that could be a batch, for example, a dozen cookies. And then what are we interested in when we look at our process? Now we're going to come back at this again, but what comes to your mind? Again, thinking of define from Six Sigma, you're probably interested in your skateboard has certain dimensions. It has maybe a certain weight, kilograms or pounds, that you're interested in. You might be very interested in the fact that the wheels stay on, that you have an assembly process, that you have the skateboard can withstand some tough use. The paint must be durable, that it doesn't get scratched easily. You have requirements for designs. You want a design so that appeals to your target market. So those are all the things we talked about in the Six Sigma part of the course. But thinking about the process overall, what else could you be interested in as a factory manager? You're interested, again, you've got your flow unit of a skateboard. How about the speed of the process? How fast are you getting your parts out? How quickly is the skateboard produced? What else could be interesting? Could be interesting here. We're going to look at that next.